Hello, this is Nicole Dominguez, and I'm from AP Physics 1, Period 7, and today we're going to go over a force toolkit problem. When doing force toolkit, the first step you want to do is to identify the system being accelerated. 2, you want to define the coordinate system. 3, you want to identify the forces by drawing a force or free body diagram, and you want to include a motion map. If necessary, you want to draw a component diagram and rotate the axes. 4, you want to explicitly write the net force is equal to mass times acceleration. 5, you want to replace the net force with the actual forces that are in your free body diagram. And if necessary, you're going to write net force is equal to mass times acceleration in both the horizontal and vertical directions. And 6, you're going to substitute in any numerical values where appropriate and solve for unknowns. In this problem, we have this system, which is an elevator that is moving upward, and these masses are inside that elevator. And this asks, how does the magnitude of the forces exerted by the top box on the bottom box compare with the magnitude of the force exerted by the bottom box on the top box for each of the stacks? So first, we're going to identify the system as each of the blocks of inside the elevator. Second, we're going to say that up and to the right is positive. Third, we're going to identify the forces by drawing a force diagram or free body diagram. And this is the motion map, so we can see that it's moving upward, velocity is constant, and acceleration is 0. Now, if we take a closer look at this free body diagrams, for each of the systems of blocks, there's a normal force acting upwards, a force of gravity that acts downwards on each object, a normal force that acts upwards on the second object, and a normal force that is in the opposite direction because the forces between two blocks have an opposite but equal relationship. Next, we'll explicitly write that the net force is equal to mass times acceleration. In step 5, we'll replace the net force, and you see here that I rewrote that the net forces for the normal forces of A on B equals B on A, and so on for each block system. And like I said before, this is because the relationship is opposite but equal. And over here we see that the net force, which is the combination of both the free body diagrams for each set of blocks, is represented over here. And those will equal mass times acceleration. In this case, since our motion map determined that acceleration is 0, then this would be 0 for each system of blocks. So, based on this, if we look back at our original problem, we would determine that the answer is A, because Newton's third law tells us that in the action-reaction between each stack of blocks, there will be an equal but opposite force applied. And so we can look at A and say that the two magnitudes are always equal in each of the stacks.